I'm going to do a problem that deals with coordinate geometry, and it's going to ask us to find the perimeter and area when it gives us some points. So we're given 3 points here, and we're being asked what the perimeter and area of triangle HEY is. So the first thing to do would be to graph it on the Cartesian axis and see what shape we have and get an idea of what we're looking at. So I've got H here, I've got E here. My last one is Y. It's at a half 7, so a half 7. I have Y up here, and so I'm going to connect those. So I have this triangle. So I need to know perimeter and area. So the perimeter of a triangle is to determine what each side length is and then add those together. The bottom one is not too bad. We can count that because we have the axis here. The diagonals, though, we're going to use the distance formula. And so the distance formula, if you don't remember, is d equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And so we're going to use this distance formula to calculate the sides of the triangle. We can just count along the bottom to know the distance of HE. So the measure of HE, from here to here, 1, 2, 3, 4, 5. That one's the easy one. It's 5 units. So we're going to use the distance formula for the second one. So if I want to know the distance from H to Y, we'll count H as our x sub 1, y sub 1, and then Y we will do x sub 2, y sub 2, and plug it into this formula. Okay, so I have double negatives here, so watch that. They're actually going to be added here. So I have 2.5 squared here, and I'm going to have 6 squared here. 6 squared is pretty easy. That is 36. 2.5 squared here is going to be 25 fourths. And this is all under the square root sign here. And so we need to add these together and then take the square root of that. All right, when we take the square root of this number, we get 13 halves. So the distance for HY, this side of the triangle here, is going to be 13 halves. So the measure of HY is 13 halves. So now we need the distance from Y to E. I'm going to leave my x sub 2, y sub 2 on Y and just move x sub 1, y sub 1 over here to E. And then I'm still using this formula, so I'm just going to make some adjustments here. All right, so we have a half minus 3, so we're going to have negative 5 halves squared plus 6 squared. This is all taking the square root. So again, we're going to have the same values here. Once we square this, this becomes positive. So we have 25 fourths again plus 36. And so this is going to be equal to 13 halves again once we add these together and take the square root. So the two sides of the triangle are the same. So that also tells us that we have an isosceles triangle here. So the last measure here is YE is 13 halves. And so we're going to add this column up, and that's going to be our perimeter. So we have 5 plus 13 halves plus 13 halves is going to be 18. So The perimeter is 18 units. And that is the answer to that question. So the question of area, we're going to need to use the area formula for a triangle. And the area for a triangle is 1/2 base times height. Well, we know what the base is because that was the measure of E, but we don't know the height yet. The height is going to be from the base of the triangle to Y. From the x-axis to y was 7 units, but the base of the triangle is at 1 since our y values here are 1. So the difference between 7 and 1 is 6. So the height of our triangle here is 6. If you didn't see that, you could draw a line that bisects your triangle, since this is an isosceles triangle, and you could use the Pythagorean theorem. You could get the height that way. But we can, since this is a very nice triangle, we can see the height there. And so we're going to have 1/2 times the base, which is 5, times the height, which is 6. And so the answer to that is 15. So we have 15 square units. So the perimeter is 18 units and our area is 15 square units. And so we have drawn the diagram, we have found the perimeter, and we have found the area for this triangle. Cheerful calculations.